changes
Yeah,
I made
he's
here.
now okay.
You have to.
Also, like I forgot to tell you, like I was a bit bummed yesterday because I just can't land a job. It's just getting so frustrating. Like I
Mm,
know I can learn things fast. I think you're a witness to that, right?
mm-hmm. Mm-hmm.
I'm getting better at algorithms, but the interviews just dried up because it's getting to the end of the year, and I don't know what to do. Like I asked Justin in the general channel,
Yep.
and he
Yep.
told me I should do networking, but I'm not sure exactly how to do it. So, do you have any tips on that? Because I have a kid, I can't go out every day and meet people for coffee and shit.
Yeah, yeah. No, I hear you. And I'm one of those people who I don't even have a LinkedIn, honestly. Like I just started using other social medias just to connect with family and that sort of thing, but I've never been one that was too much into social media. And that's because I come from the sales management background. I come from that sales background where there were people on my team who would be like, "Oh, I'm going to reach out to people through social media." I'm like, "You could go for it, but it's not the same type of connection as if you meet someone face to face." And me and my teams, we all knock on people's doors. Like we're the
Yeah.
ones knocking on your door. You open the door. Hey, how are you? Sorry to interrupt,
Mm-hmm.
or just start the conversation going. And it's like it's just so much more of a real connection. So I never looked at social media as a serious thing. You could definitely reach more people in a short period of time, but the connection is so weak compared to in person. So I'm not into that, but I do know people who have been successful. They actually had a strategy similar to what Justin was talking about, where they would. It wasn't as much like, "Hey, I'm a engineer looking for a job." It was more like asking engaging questions that kind of just got a conversation started, which makes some sense. But
Yeah.
there's so many strategies, man. At the end of the day, it's like you have to choose one and just stick with it and just be consistent with it. And the thing is, like, let's just say the goal is to reach out to 5 people every single day on LinkedIn with engaging questions. If if you're reaching out to 5 people a day, so 35 people a week, and you're only getting one response every 2 weeks, that means you're getting one response for every 70 people. So
Yeah.
if you reach out to 70 people a day, are you going to get one response a day? Is that worth your time? So
Mm.
in my opinion, either you need to increase the quantity of people you're reaching out to, or you need to change the method in which you're reaching out to them.
Yeah.
Because the way that you're approaching them is not working. So you could say like, all right, right now my number is 1 in 70. For every 70 people I reach out to, I get one response. So scale that up. I mean, scale it down. Go back to like 5 people a day, but do 15 people a day. 5 people with this strategy, 5 people with this method, 5 people with this method, and then compare those numbers. Like, which one of those three methods are working better? Is it your original one where you're just reaching out, engaging questions? Is it the second one where you ask a question and send a photo? Or is it the third one where you send like an entertaining video and say, "Hey, you're a recruiter for the tech field. I thought you would think this was funny." Or, like, what do you have to do? How do you have to change your method? How do you have to change your approach? How are you communicating to people that's going to maximize the engagement and the response and that sort of thing? And literally, that's what I was doing when I first started sales. When I first got into it, I realized I had this conversation with this guy, Zach, and he thought that you just have to talk to as many people as possible. Like everyone who walked into the store, you would say, "Hey, would you like to see if your home qualifies for solar?" And they'd be like, "Yes or no." If they said yes, you looked up their home to see if they qualified. If they said no, you're just like, "All right, great, have a good day." Next person, "Hey, would
Yeah.
you like to see if your home qualifies for solar?" And he just asked this question every single time, but he asked it to a high number of people. And that strategy worked. I was on the other side though. I thought that the way that you ask and the questions that you actually ask make a big difference. Like if I ask everybody, "Would you like to see if your home qualifies for solar?" I'm going to get one person to stop. But if I ask
Yeah.
the next person who walks in, um, "Hey, what's your favorite song? I'm looking for some music to listen to while I work and talk to customers. What song would you recommend?" They're gonna stop and give you an answer. They're gonna stop and talk to you. Everybody is gonna stop and talk to you if you ask them that question because you're not
Yeah, but
talking to them about solar. You're talking to them about music.
But
So
doesn't that come across as fake? Like I'd be kind of like,
not
okay,
if
you
you
want to
really
hear
are
about this song?
not if you really are looking for music.
Okay,
Yeah,
okay,
if I really am looking for music, like
I'll just feel like cheated out. Like, oh, he's asking about music, but all he wanted to do was to try to sell me, solar panels or
nah,
something like that.
you still have to be
But
authentic.
yeah,
If I'm not looking for music,
exactly,
I wouldn't do that.
exactly.
You have to do something that's authentic to you. And then I would be like, "What are you looking for?" "Oh, paint, follow me." And I would show them where the paint is. Like I was basically like a Home Depot, or I was like a Home Depot employee. I knew more about the layout of the store than any of the employees who actually worked there. And I helped out more customers than any employee who worked there. So it's like
Hmm.
if you're going to help them out first, then it's almost like a tit for tat where they almost feel an obligation to at bare minimum listen to you. So like how can you help recruiters? I think that's a good question, because if you could help recruiters, they're going to feel obligated to help you.
Yeah, I agree.
That's kind of where I would come from it. If I was actually trying to get jobs, I'd be like, how can I provide value to these recruiters? Like, what are they looking for? Screw what I'm
Hmm.
looking for. What are they looking for? And I would approach it like
Yeah,
that.
yeah. I get it. Like I might have to try, but I think like, because at the beginning of the year when I had my job, everybody was like after me, and I quit my job, but I haven't changed my LinkedIn.
Hmm.
So, because I was afraid, okay, if I put on my LinkedIn that I don't have a job, recruiters are not gonna reach out because sometimes people are like, oh, if he doesn't have a job, he's probably bad.
Hmm.
Uh, Maybe I should change that because it's getting annoying, like having to tell people that I still work there. I just don't like the feeling.
Yeah.
But I've been told that if you are like if you have a job gap, that's a red flag or something.
Hmm.
Even though I have a good reason, which is my son was born and I want to spend time with him.
Yeah. 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 I wouldn't say wanted to spend time with him. I would say needed.
Yeah,
Yeah, like little words make a big difference sometimes too.
yeah, I
Because
agree.
wanted is like,
Yeah,
oh, what you just didn't want to work and you wanted to spend time with your kid. If you said I needed to, I would assume that it was something like family related, more like serious. The word
yeah.
needed.
I needed to give support to my wife. Otherwise, she'd be carrying the whole burden, right? Not it's not a burden. Like I don't know what the word is. The responsibility.
Yeah, yeah, responsibility.
But yeah.
Yeah, man,
Anyway,
it's not easy.
yeah,
It's not easy. I know
it's
that.
not easy.
So
I know I'm capable of achieving good things, but yeah, man, it's hard. But I'm not losing hope or anything. It's just like I just like so excited to do it, and I just can't get it. Like,
yeah, you gotta analyze. You gotta analyze it very methodically, man. Like the way I said to do it. Like what results are you searching for? You're looking for 5 interviews a week. You're looking for 20 conversations a week. Like, what are the metrics? How do you measure your results? And if you're not hitting those
honestly,
numbers, you need to change what you're doing, because what you're doing isn't working.
yeah. Honestly, 2 interviews a week would be nice. That'd be really nice. At least you always have something going, right?
Yeah, start with some
Especially now that
goals.
I'm getting better at, especially now that I'm getting better at algorithms, I have
Yeah,
a better chance of landing a job. But I feel like networking is really important.
definitely,
Uh,
definitely. I would definitely check out some in-person groups in your area, or even host an in-person group yourself. That's how I started, you know.
yeah, I'm gonna
I
try that.
I was
But
just looking
I don't.
for an in-person group around here, and I couldn't find one anywhere. And I was like, I guess I'll schedule one and see who shows up. And people showed up, you know. So Justin's one of our
Yeah,
in-person guys. He comes to the local. He actually studied. I think he has his master's in machine learning. He's really smart.
that's awesome.
Yeah,
Can
good
you hear
dude.
me now?
Yeah. Hey, what's up?
Yeah,
Oh,
how's it
nice.
going?
All right. Good. Yeah, my input was on the wrong device. So,
Ah,
thank you
gotcha,
for
Yeah,
the heads
gotcha.
up.
yeah. I was
Oh,
just
man.
venting my frustrations.
No, I mean, I heard the entire thing. I just couldn't contribute. But, man, that
Yeah,
sucks.
but you heard it.
Uh,
But did you see the tears? You didn't see the tears. Just kidding.
yeah, I have been watching you, actually. So, yes.
Oh, okay.
All right, we'll get to it because it's already 8:15 and I don't want to run over too late. But let's see. So we got if you check out, so we have our rules where everybody drops into the rule channel when they join the server. We have our start here. I took the events out of the start here and I just added these 2 new channels that I added to the server today.
Yeah.
So we have our choose a location server and we have a choose a specialization channel. So if you go to choose a location, we have these, I believe it's 15 locations right now. I'm going to add another 15 in like a couple weeks because I'm expanding out and advertising now in all of these locations. So we should see like a major increase in membership on the server in the coming weeks. So yeah, so feel free to go ahead and choose your location. And when you choose your location,
I did.
One of these channels is going to become available to you. I can see them all because I'm the admin for the server, but when you click one of these, you'll automatically, the channel that you clicked on will become available so you can communicate with people who are in your area. So that's that.
I picked Illinois and web developer.
Cool. Yeah, and then I was going to say, I also have the specialization here just with some of the top fields within the world of computer science, and same thing. You could choose more than web developer if you want to. You'll see the ones that you choose. Like I chose just a couple here, so just throwing that out there. You're not going to see everything I see, but you'll see whatever roles you self-select, you'll see. So feel free to do that. I don't know if you chose one, Alex, but just a heads up.
Before we start, did you pick anything for Friday?
No, I'm not looking at anything for Friday. I think if we do that pair programming idea that I was talking about, it's more likely to be like a daily thing because that's not something you could really do once a week.
Because I love to do like anything related to backend. Like if you want to do it, I'll show up.
Yeah, cool. I do wanna. I'm gonna go to. If I do the pair programming thing where we're building like the ambassador program, that's going to have front end and back end.
Okay.
For sure.
What language, Daniel?
I mean, I like C# and Node. I would love to go through the C# route, but I understand that Node is probably easier for me.
Okay. I was just curious. Yeah, I don't know anything other than Python for backend, but I'm willing to learn whatever,
Yeah, I work the place I worked at. They use Python for backend, but it's such a small startup. They don't pay nearly enough, so I wouldn't recommend working there.
Yeah.
But yeah, so yeah. We can start the algorithms if you guys want.
Cool. All right. Tonight's is pretty similar to last night's, but it's a little bit different. So it's another challenging, like tricky one, but it's almost identical to last night's. So this is the problem here. What we're gonna do is I'm going to share the problem, make sure both of you understand it. Then I'm gonna go ahead and share the brute force solution to you guys. I also have an optimized brute force solution, and then I have like a more efficient O of N solution too. But after I share the brute force solution, then I want to give both of you an opportunity to just like think about it, think about other solutions for a couple minutes. And before anyone starts sharing, I want to hear both of your thoughts. Like I want to hear Alex's thoughts on just like his own approach, and I want to hear Daniel, your thoughts on your own approach. And then we'll go ahead and we'll explore those options there. I just want to give both of you an opportunity to share ideas. Whether it's like a valid, complete solution or not, I just want to like get both of your thoughts on it before moving on to actually writing any code. All right, so, and then I'll share my 2 solutions, the other 2 solutions on top of my brute force if we have time after that. So given a 0 indexed array, or integer array nums, return true if it could be made strictly increasing after removing exactly one element. So similar to last night, we're removing exactly one element, but instead of checking frequencies like we did last night, we're checking to see if it is strictly increasing or false otherwise. If the array is already strictly increasing, just return true. So we don't have to remove one, but we can remove 1. So in this case, we have 1, 2, 10, 5, 7. If we remove 10, then it's strictly increasing. 1, 2, 5, 7. But if we had like 1, 2, 2, 7, that's not strictly increasing. Each element has to increase. It can't be equal to the last one. So this one would be true because by removing 10 at index 2 from nums, it becomes 1, 2, 5, 7. 1, 2, 5, 7 is strictly increasing, so return true. With this one, you would think like, okay, 3 is higher than 1, so we could just remove 3 and it'll be strictly increasing. But no, because the number that comes before 3 is 2, and after 1 is also 2. If this 2 was like a 5, you could remove the 1. Or if this 2 was a 0, you could remove the 3, because then it would be 0, 1, 2. But this is like a tricky case here. So this would actually return false. And the reason why this is tricky is when I first did this, I iterated over the nums array. So starting at the first one, went to the second one, went to the third one. And if at any point nums I was greater than nums I plus 1, I would assume that all we had to do was remove nums I or nums I plus 1, which isn't the case. I was tricked on that. And then this is the third case, just 1, 1, 1. This is also false because no matter which one we remove, it's not going to be increasing. We're going to end up with 1, 1, and 1, 1 doesn't increase at all. It's just equal. So the length of the array is going to be anywhere from 2 to 1,000, and the value of each element is going to be anywhere from 1 to 1,000. So does anyone have any questions on the problem? Does the problem make sense?
Yeah, it does make sense, but I can't think of a solution because you can't sort it, right? So that would be a problem. I don't think you can sort it.
No, you can't sort it.
No. Like the first one, you because for the first one, I thought, okay, so I have an array, and then I'm gonna get a different array, and I'm gonna like copy the original array, right? And then I'll check like I'm gonna sort it, and then I'll check if the the elements are the same. Like I'm gonna check 1, it's gonna be 1, 2 is gonna match 2, and then 10 is not gonna match 5, and therefore you could actually remove 10. But I don't see how to solve. I can't think of a way to solve this problem like at all.
Yeah, I'm going to go ahead and show you the simple brute force solution, and I'm going to show you with this example, and then you can and then I'm going to give you both an opportunity to just like think of either optimizing that or think of another solution. But this is going to be the first solution. So what I want to do is I want to see if this is strictly increasing just without changing anything. Like if this is just, it's possible that I don't have to remove anything. So how do I find out if this is strictly increasing without actually doing anything? And so I want to actually create a separate function here. I want to create a function to test if the array is strictly increasing, because I could use this. You know what I'm saying? Maybe it is, but maybe it's not. So once I have this function, I could test if it's strictly increasing or not. Then what I'm gonna do with the brute force solution is I'm gonna iterate over the array, and for each element in the array, I'm gonna remove that element, and I'm gonna check if the array is strictly increasing. And if it's not, I'm gonna remove the next one. I'm gonna check if that's strictly increasing. If not, I'm gonna remove this one, see if that's strictly increasing. I'm gonna remove that, see if that's strictly increasing.
Okay.
You could see though, once I encounter this 10, I find an array that's strictly increasing. So if at any point while I'm iterating over this array, removing our current element and testing to see if it's strictly increasing, if I ever find an array that's strictly increasing, then I just return true. But if I make it all the way to the end of the array without finding an array that's strictly increasing by
Yeah.
removing one element, then I know that I can never have an array that's strictly increasing by removing one.
Can I try it though before you code it?
You want to try to code it?
Yeah, I want to try to code it because otherwise, you know, I'm here to get my hands dirty. If I fail, I fail. You know.
Yeah, just jot down the pseudocode before you type any code.
Sure. Can you please send me the link for the
Yeah.
VS Code?
Yeah.
I don't know if Alex wants to try.
No.
The VS Code, please. Yeah, you send me the LeetCode one.
There you go. You got both.
Thank you.
Cool.
Yeah. What was I going to say? Yeah, I can check the pseudocode, no problem.
Yeah.
So yeah, let's start by creating the function to test if the array is strictly increasing. When you say strictly, you mean like we can't have two numbers that are the same, right?
Exactly.
Okay, so let's what shall we call it? So let's call it just like function strictly increasing. We're gonna receive nums, I guess,
yeah.
or an array or whatever.
Yep.
Maybe you want to be more generic. I don't know, because it could be any. Yeah, but it's gonna be numbers. Like it's gonna compare numbers. So just call it numbers. So you could do like a for. Do you prefer doing a for loop with I and stuff, or
you want to just jot out all the pseudocode before you even type any code, so we understand like what each step is doing?
Sorry.
Just for Alex.
Iterate over the array. Or sorry, loop. I'm gonna say just loop.
Iterate or loop
over the array. Yeah. And then before I write it here, I gotta say, check if current element is different from the next one.
Different?
Different, yeah, because sorry, same. Right. Wait, yeah. It's same from the next one.
Well, what if this one is 1 and this one is 2? They're different, but that's good.
Yeah, like I want to check if they're the same, right? You don't want them to be the same, right?
You don't want them to be the same, or you don't want the current element to be greater than the next element. So check to see if the current element is greater than or equal to the next element.
Okay.
Yeah.
So basically,
because they could be different. They could be different. As long as the current element is less than the next element, we're good. We just don't want the current element to be greater than or equal to the next one.
I get it. So yeah, I think for now, check if the current element is smaller than the next one. I think we can start it from now. Do you think we need more pseudocode? Just for the function?
If the current element is smaller than the next element, what do we do?
If it is smaller, then the next element, we can flag something as true, like it's like not strictly increasing or something like that.
We're just gonna check if it's greater instead of smaller, and if it's greater, we'll just return false.
Okay.
But if we make it through the entire loop, then we'll actually return true from this function.
Okay.
Because then we move from the beginning of the array to the end of the array without ever finding a current element that's greater than the next element.
Okay, I get it.
What's going on, Joe? I just saw you popped in here. You're muted. I don't know how new you are to Discord, but there you go.
Okay, I'm on.
What's up? Yeah, we can hear you. What's up?
I'll go on. I'm very little about this.
Can you see my screen?
Yeah.
Yeah, if you just double click on my name, my screen should pop up. Daniel's typing some code right now.
Oh, I see the active discussion.
Cool. Nums I is less than less than
or oh, sorry.
Greater.
Yeah, I'm a bit tired. I'm sorry.
all good.
Yeah, I was tired yesterday. I'm tired today. I need to do some exercise, I think.
I'm like the debugger. I'm your debugger.
Yeah. And also, yeah, okay, so yeah, let I 0 nums length, so the element's greater than
Or
next element, or what was the other condition? I forgot.
just look at this third example.
Are the same? Okay.
Yep. Greater than or equal to.
Okay. Yeah, very technical terms, equal to. I usually see like smaller, bigger, same.
Yeah, with pseudocode, it doesn't really matter the technical language, but
yeah. Okay, so check if the current element's greater than or equal to the next element, then return false. Yeah, I think we're doing that.
Yep.
Otherwise, just return true, which we can do here. Return true. So our function should work, hopefully. Right.
We just have this right here. This.
Oh.
Just have to put the equal sign after the bracket, but besides that, yeah, everything looks clean. It looks good.
Yeah, I've been slower these couple of days. Sorry.
Nah, you're good,
Okay,
man. You're good.
So iterate over the array, and then what are we first we have to check if it is, yeah. So check before we iterate over the array. We should check if it is strictly increasing, right?
Yeah, you could do that. Just one quick check to test it out.
So
you're right. Because in that case, then there's no point of removing anything. We're just wasting time.
Yeah. So so if if
I didn't want 20 chickens right now. I feel like
so if this is how do I check this? Because we're calling a function and it's going to return either false or true.
Yeah,
but I don't want to return.
That's good right there.
Okay, so if this.
Yeah, because that function call is going to return true or false based on the current state of nums. So if it returns true, then it'll execute the block of code. If it's not strictly increasing, it'll return false. So then in this case, you would just you know that.
Else. Return false. Like this?
No. Because we're just checking if the array that we were given is strictly increasing. If it is, then we could just return true. But if it's not, then we actually have to do our brute force solution, removing each element one at a time.
Oh, you're right, because the whole point of it is returning the Boolean, right? So sorry. Okay, so if it is strictly increasing, we don't have to do anything. We already have something that works. We can return true. Now we can iterate over the array. Do you think I should use a for loop or for of or?
Yeah, you're gonna to slice the array.
Yeah, I'm gonna need the index.
You're gonna need the index. Yeah.
So let I equals 0 again. Basically the same thing as this, and you're just gonna copy this. So I'm gonna iterate over the array. Okay, so let's see what we do here. What are we trying to do? We want to slice it, right?
Yeah.
But but the thing is, we don't want to slice it without creating a copy. We want to create a copy, right?
Yes.
So
exactly.
So let's. I don't know. I think const works. You don't need to. I don't think you need to use let because you're not really reassigning anything. You're just slicing.
Yeah.
So const. What should I call it? copy nums or something like that. I don't know. I'm not good with the names. So yeah, we can slice it. So copy nums and slice. By the way, I just realized something. We might not need this.
Why?
Because I remember what I told you about the two sliced. Let's see if it has two slice here. Nums, two slice. No, I don't think they have it.
No, that's not.
Yeah, I don't think. Because it's a new thing. I don't know if they have it. Okay, but because basically this doesn't maintain the integrity of the initial array, and two sliced does. But anyway, let's do it this way then. Even though it's not the best way. So okay, so copy num slice. You want to slice the I element. Yeah, because first iteration is gonna eliminate 1, then it's gonna eliminate 2.
We're gonna need 2 slices though. So let's just say that I equals 2. We want to remove this 10. So to remove this 10, we're gonna do nums slice 0 to I plus nums slice I plus 1 to the end of the array. So that'll give us this first.
Yeah, you're right.
That'll give us this first slice and this last slice right here without I.
I wish we would do like a map with a delete or something, but it's not. It doesn't make sense. So yeah, I agree with you because you have to maintain the rest, right?
Mm-hmm.
Okay, so I'm gonna just put it there. Copy nums. So not nums, but copy nums slice copy nums. So we have to save it here. So do like const. Oh, sorry, const new, what should we call it? New, because there's a word that I'm looking for that I don't know what it is, like new version, new iteration, new sequence or something like that.
You honestly don't even have to create this variable right here. You could literally just do this. Do that and then do the same thing with this.
Okay.
With nums though, and just scratch that whole line, because then you're creating an array. The nums dot slice 0 to I, and then you're spreading it out, and then nums dot slice just I plus 1, so starting at the element after I plus 1 and also spreading that out, so then it ends up inside this array, and then you have the copy that you need right there. And nums dot slice is not modifying the array in place, so we're actually not modifying nums by doing this. We're just creating a new array and storing that in copy nums, and then that gives you the array that you need to test. That would give us, if I was 2, that would give us that right there, basically.
And then we test it again, like, right? We test like if it's strictly increasing, right?
Yeah, for each character, we test if it's strictly increasing.
So we can do just copy this and do if strictly increasing, copy nums, return true.
Yep.
And of course, it's gonna run it over and over, and when it exits the loop, it's gonna return false.
Yep. If you make it through the entire nums array without ever finding a subarray that's strictly increasing, then yes, it's impossible.
That must mean that it's already okay.
Yep.
Okay. That seems like a good solution.
Yeah, let me test it out, see if it works.
Is it the brute force?
This is the brute force. Yep. True, false, false.
Why do you call brute force? Because you try every single iteration.
Yeah, because you're testing the array with every element removed.
Mm-hmm.
So you're testing it with 1 removed, you're testing it with 2 removed, you're testing it with 10 removed. For every element in the array, you're doing an O of n operation. So for every element inside the array, you're running this strictly increasing. So you have this for loop, and this strictly increasing function is a for loop inside a for loop. So this is going to end up being O of n squared time.
Yeah.
And what about space?
So what about space?
O of what?
Well, we're O1 because one no O of n because you're creating the same copy here inside.
Exactly. O of n space.
Yeah. And it's O(n) squared because you have you're calling the function inside here.
Mm-hmm.
Inside the function there is a for loop, right?
Exactly.
Yeah.
Yep. Yeah, so
Yeah,
that's
that's
that,
kind
and
of
it does
cool.
work. I'm gonna go ahead and post it in LeetCode because sometimes they have edge cases that
Yeah.
aren't working. So let's run this bad boy, see what we're
like
getting.
the SOAR one yesterday.
I know. Nah, like the mathematical
so
one a
frustrated.
couple days ago. Yeah, so this one passes, but we're at 15% for runtime and 25% for memory. So it's just
Yeah, pretty bad.
not a good solution.
Yeah, I agree.
Do you understand this, Alex and Joe?
Can you hear me still?
Yes.
Jim, can you hear me still?
Yes, I can hear you.
Yeah, we can hear you.
Okay, well, I was actually tickled pink because this looks a lot like Java. I took 30 years ago at University of Eastern Equivalent, and it's in fact JavaScript. Where we got to look at these colors, use something called Notepad++.
Yeah.
To introduce the colors.
Uh-huh.
General coding not changed much from basic Java 30 years ago.
Mm-hmm. All right, so you did some Java coding 30 years ago?
I'm sorry?
You did some Java coding 30 years ago?
I took a semester-long class while I was a process control engineer doing a conversion from one system to the state-of-the-art system in 94, 95. Also taking Java at that time.
Okay.
Wow.
Nice.
That's amazing stuff.
How long have you been back in it?
Created 95, right?
I have not seen this in 20 years.
Wow.
25 years.
Wow,
I really
okay.
only took it to understand it at that time. If we have a chance to wrap up, I'll indicate right now.
Wow, what made you want to get back into it?
No. It's a little bit like a relative of mine who graduated in computer science and is really doing design and project management over UI UX.
Mm-hmm.
And I know matter of factly that I will be getting into Python, which is called something else now. And the de facto answer is I'm going to know all the software for business enterprises that are pretty much done, but I understood a certain degree of coding would be needed in things like WordPress to get all the functionality good out of it.
Mm-hmm.
Plus, I'll be getting in big data. I've already gotten into ESRI, ArcGIS, geospatial, and we'll be getting into Tableau, and they use a lot of coding to handle big data now.
Yeah, nice. That's interesting. So what have you been doing for the past couple decades since the last time you took any coding stuff? What did you do for your
I am
career?
disabled. I am disabled. That's about as far as I wanted to get into it.
Yeah, yeah.
And working became impossible.
Gotcha, gotcha. All right, yeah, no sweat. You don't have to go into it. But thanks for joining us. There's a couple other events that I think that you'll fit really nicely into as far as the introduction of web development type stuff and potentially the machine learning stuff, because the machine learning is heavy with data science. So it sounds like you already have a fair understanding of that. And then the introduction to web development will give you all the fundamental concepts you need to really get back up to speed and be able to understand everything we're doing here. So yeah, thanks for joining.
Yeah. Oh, thank you.
And then Alex, does this make sense to you here?
Sorry, I'm meeting right now, but yes, I'm following along.
All right, cool. All right, so I'll give you guys do you want to try to think of a solution where you could optimize this? Do you want a hint? What are you thinking? All right, so I'm going to go ahead and just start breaking down the optimized solution. It's very similar to this one because we're going to be using the strictly increasing function again. So I'm going to go ahead and just go over here, and I'm going to bring over the strictly increasing function that Daniel created. Now, the big difference between the brute force that Daniel just typed out and the optimized brute force is with the brute force solution, we checked whether our new copy nums array was increasing for every element that exists. So worst case scenario, in this example where we have 5 elements in the array, we're going to be checking this strictly increasing. We're going to be checking that 5 times. So if we ever get an array where the current element is greater than the next element 2 times, like in the beginning of the array and at the end of the array, that means that it's not strictly increasing. There's no element we could remove that's going to make it strictly increasing because there's it's happening in 2 different places. So in that case, it's going to be O of n squared. We're literally going to do O of n for every element inside of the array. So that's worst case scenario. Now, with the optimized solution, the thing that we're going to do is the first time that we encounter, it's going to be structured a little bit different. So this one is structured where if at any point we encounter an array that's strictly increasing, we just return true. Now in the optimized solution, we're going to put return true at the end. So we're going to be able to do one check. The first time that we encounter an element that's greater than the next element, we're going to, let me just show you what we're going to do. We're going to do 2 checks. We're going to, let me just post the array twice. So in the first check, we're going to remove the current element. In the next check, we're going to remove the next element. And we're going to test both of these. Because we know by removing those 2 right there, if we check this one and we check this one and neither of them are strictly increasing, we've accounted for both elements that were at like the anomaly spot, like where we detected an anomaly in the increasing nature of the array. And so if neither of these arrays return strictly increasing, that means that there's another location within the array somewhere. Either it's later in the array because we're going to do this once we encounter the first one. So that means that there's an anomaly. There's a decreasing somewhere else in the array. And if there's a decrease somewhere else in the array, then at no point are we going to be able to create a strictly increasing. Because even if we continue going and analyzing elements, when we reach that next anomaly, when we reach that next current element that's greater than the next element, then that means now we have an anomaly in the beginning of the array that we already encountered maybe like 50 elements previous or something. So once we encounter this first one, which is the 10, we remove that current element, we remove the next element, we test these two, and if neither of these, if this one returns true for strictly increasing, or this one returns true for strictly increasing, then we just return true. But if neither of those two checks pass, we just return false. Just right away. We know we don't have to check anything else. So I'll go ahead and I'll jot the pseudocode, and then someone could type it out. Alex, if you want to give it a shot typing out some code, you could hop into the code editor too. So this one, if at any point we're checking to see if we detect an anomaly. So we're going to iterate from the beginning of the array to the end until we find a current element that's greater than the next element. If we iterate over the whole entire array and we never find one that's greater than the next one, then we're going to just return true. We've never encountered one. That means that the entire array was strictly increasing. So we're basically doing that check that you did in the brute force, this first check, with our main loop. We're basically checking if it's strictly increasing with that first loop. Then, within that loop, if at any point we encounter a current element that's greater than the next element, we do those two checks. We create an array called without current, and we'll create an array called without previous, and we'll run strictly increasing function on both of those, the without current array and the without previous array. And if either of those return true, we just return true. And if neither of those return true, we just return false. So this you could consider O of n squared, but it's not. Because the first time that you encounter one, you're going to be doing those checks. So really it's O of n plus n plus n. Worst case scenario. So iterate over nums array, and the only check we're doing is if and we could starting at position 1. So if current element is, or I'm going to do it like this just to make it simpler. If previous element, and so you could look at it in a different way, is greater than current element, then we do a couple things. We create a new array without the current element, and we create a new array without the previous element. And for each one of these arrays, we check, pass without current, this is our array, into strictly increasing. If true, just return true. And then in this one, same thing, check, pass without previous into strictly increasing. And if true, return true. And then if both of these checks pass and neither of them return as true, we just return false, because we know we know that besides this current like anomaly in the array where we detected our current and our previous are not strictly increasing, if neither of those return true, we know that there's somewhere else in the array that also has this situation. And so in that case, we could just return false. All we need is these two checks. And based on these two checks, we have all the information we need, and we could just return false right there. So this is slightly optimized. Some people would still argue that it's O of n squared, but it's not. Never at all will it be O of n squared. Let me think of a situation if it might be O of n squared.
Jim, I came up with an idea that I would like to test later, because I think it might work, but I'm not sure. I want your input.
All right, cool. Do you want to type this code, or you want me to just jot it out? Or Alex, you want to type a little code? Or Joe?
Yeah, if anyone wants to try, be my guest.
I can, yeah, I can start it, but I'm still kind of confused by the syntax of JavaScript in general. So,
Okay.
Not confused. I just feel like it's like partly cloudy. I'm working on it every day, but yeah, I don't want to like waste a whole bunch of time.
Yeah, no sweat.
Jim.
Yeah.
Maybe you can do it in Python. Like, I would like to see the code in Python. I wouldn't mind.
Yeah. Do you have a code editor?
I mean, ChatGPT, but oh man.
Yeah, I use PyCharm for Python. I've never actually configured a Python. I know you use like venv, the configuration file to actually get it set up, but I've never done that. So if you want to share your screen and just go into your code editor that you have Python set up, that works. If you're more comfortable with Python, but I know you're also trying to learn JavaScript too, so.
Yeah, I think I don't know how that would go. No, I don't think so right now. Yeah, I feel like I'm gonna completely freeze on this right now.
All right, no sweat. I mean, you would just take it one line at a time, and if you make any mistakes, that's totally fine. Actually, if you make mistakes, that's good. It's good if you make mistakes, because that's where all the learning happens. So, no pressure, but I definitely I'm gonna encourage it. You know.
I know. I think like next week I want to definitely participate and like, all right, just like getting started in it, and then kind of not yet. I don't think.
Yeah. All right, then let's both Daniel and I will go ahead and write code for this just so we can bust this one out, because I want to show you the third solution, and it's like 9 right now. So let's just bust this one out fast.
Yeah, don't forget I want to try my solution too, the one that I came up with.
Okay.
On Notepad.
All right, so.
Okay, so iterate over now. Started.
So I'm just slicing the array from 0 to I and spreading it. So nums.slice I plus 1. That's our without current. And then I'm going to create our without previous. So I'm just cutting out the current and the previous element. Nums.slice 0 to I minus 1. And then nums.slice I believe that should be good. So now we have the array without the current element, and we have the array without the previous. And then we just check.
Jim,
yes.
Isn't it greater or the same as the current element? Line 8.
It is. It's greater than or equal to the current element. Yeah. So if the previous element. If the previous element is greater than the current element. Yeah, if the previous element is greater than or equal to the current element. Yep.
Okay, or equal to. Okay.
Yep.
Because I remember that being the case. Okay, so if we return So if the previous element is greater or okay, we return false, I believe, right?
No. If that's the case, then we run this code that I'm writing right now. So let me go ahead and put this code inside this.
And then you return true at the end. False, right?
Yeah, so
no, you said return true.
If neither
true. Okay.
At the end of the function, if we never find a mismatch in this whole for loop, then we return true at the end. But if we do find a mismatch, then we just remove the current, we remove the previous, and we do a check with the without current array, and we do a check with the without previous. And if either of these return true, then we just return true. But within this check, if ever we encounter the anomaly with the previous is greater than the current, if both of these tests don't return true, then we return false. We know that there's another discrepancy somewhere in the array, so we could just return false after those two checks.
You said this is not O(n) squared, but why?
Because
so
O of n squared would be where we are running this strictly increasing function for every single element in the array. In this situation, we're not running this for every single element in the array. We're only running these if we encounter an element that's greater than the next element. If we never encounter one that's greater than the next element, then we never run any of this internal stuff. It's just O of n. If we do encounter one that's greater than the next one, then we only run this once.
Okay, so just to see if I understand, the brute force one, we were checking every time, and then like we would check if it was true or not, and then like return it. This one, it's only going to return if it's true. So it's only gonna get there and actually run the function if it's true.
It's only gonna run the function when we encounter the first element that is greater than the next element. If we never encounter an element that's greater than the next element, then the array that was passed into can be increasing function was already strictly increasing. So we would never, this line of code will never turn out to true. If at any point this line of code turns out to be true, only then do we run the strictly increasing function.
Okay.
And so the brute force, we're running the strictly increasing on every single element in the array. Worst case scenario in this optimized version, we run strictly increasing on just one element.
Okay.
The first one we encounter.
So line 7 is O(n), right? Because it's just iterating through the array. We have a condition here. So we only run the function, which would be O(n) squared, if this condition is true. But what is like the worst case scenario like?
Worst case scenario is O of n plus n plus n.
Okay, because we have O(n) here, and you have two checks of which one, like of which they're also n, right?
Yeah. So if we ever return true to this and we find a current element that's less than the last element, or like if our current element is greater than the next element, so it's not strictly increasing, then we do O of n with this and we do O of n with this, but it's not O of n for every element. So it's just O of n plus n plus n. But if we never encounter this, then we just iterate over the array one time. So in that case, it would just be O of n. It's either going to be O of n or O of n plus n plus n. And unless if we find out this without current one, and then we pass without current in here, and this one returns true, then we'll never actually run this. So it's either going to be O of n plus n, or O of n plus n plus n. O of n if we never find something that matches true for this. O of n plus n if we do find one, and the without current array is strictly increasing. And O of n plus n if this returns true. The without current is not strictly increasing, but the without previous is strictly increasing.
Mm-hmm.
Or not. Yeah. Once we check this, we never continue this for loop. We break out. We're either returning true or false once we encounter one that's greater than the next one.
Okay.
Mm-hmm. You want to go ahead and share your solution that you came up? Is it working?
No, I haven't tested it. I was just thinking of a way that to make it using sums.
Mm-hmm.
Basically, but I think it's pretty much like the strictly increasing function. Where can I type this?
I could go ahead and create you another file if you want.
Yeah, thanks.
There you go.
Yeah, can we copy and paste the optimizer or something, or the brute force into that, please?
Yep.
Okay, this is probably completely wrong, but it was just a thought, like, because I thought, okay, bear with me, okay?
Mm-hmm.
So what I'm trying to do is, like, I check the first number, which is 1, and I add with the same number. So that would be 1 plus 1, which equals 2. And then I check if the sum of the same number, which is 1, plus the next one, so that would be 2. It's if like the 2 is greater or equal than 3, which is not. So it's just going to, and yes, I realize, like, it's kind of weird. But then I'm gonna check again, right? I'm gonna check next number is gonna be 2, so it's gonna be 2 plus 2, and 2 plus 10. So 2 plus 2 is 4, and 2 plus 10 is 12. 12. So 4 is not greater or equal to 12. Now we're gonna check this. 10 plus 10 is 20, and that is indeed bigger than 15. So we would do that. That would be like the end of it, because we do have a number that the sequence is greater or equal than the sum of the current element and the next element. There's probably some edge case here where.
What's the difference between checking just the current element against the next element and the way that you're doing it, where you're doubling the current element with the next element?
Because I feel like the way I'm doing it, because sure you could check like 10 and 5. But I don't know, for some reason I thought having some kind of sum, like a variable that would even, like, maybe here, like, let sum equal 0, like, and then check the sum of it every now and then, and whatever has like the biggest sum, you remove the index of it. Like, let's say this one is 20, right? This one is the one with 5 would be 15. Let's see what it does, like the last one. The last one is going to be 5 plus 5, which is 10. And this would be 5 plus 7, which is 12, right? Mm-hmm. So the only one that has this issue where the sum of the current number with itself is greater than the current number with the next element, it's 10. It's the only one. I don't know if it makes any difference or not.
Yeah, I think you're just adding complexity that you don't need, because if at any time you double the value of the current element, so you encounter like 10 and you do 10 plus 10 for 20, okay, and then you do 10 plus 5 for 15, that you're still going to get the same result as if you just compare 10 to 5. 10 is greater than 5. 10 plus 10 is greater than 10 plus 5, but also 10 is just greater than 5. It's just simpler.
Yeah, I guess. So, yeah, it makes sense. So maybe we could have something like, we define the sum to be 0, right? We initialize it. We get the sum, and then so if sum, then return. I don't know if return false or true, but I guess one of them. I don't remember which is correct. Like my logic might be a bit faulty, but you do this for everyone, and of course you could do also like sum equals max sum, or this, and if this is the case, maybe you could check the index, the current index, like if sum if sum, I don't know, man, slice something using the index. Do you see where I'm trying to get? Like I'm trying to see, like I try to get it's not a sum anymore, right? It's like something I don't know, condition. Yeah, I'm getting lost in my thoughts here, but what I mean is that I want to be able to see, which is maybe it's like it'd be like largest number, like const largest number equals 0. So largest number.
I think you might be connecting this problem with another problem, because the largest number is less relevant and the sum is less relevant. The only thing that matters is if the current element is greater than the next element.
Okay.
There actually is more that matters besides that. There's like a little bit more information you could collect based on your current element, but yeah, I don't see how the sum would help you find out the answer, because regardless, even if the sum, let's just say you get to the element of 10 and 10 is greater than 5, that doesn't mean that it's false. Actually, the first one is true. So it can be strictly increasing by removing one element. So even though the 10 is greater than the 5, that's fine. What we want to do at this point is determine if the elements after the 10 are increasing over the elements that are before the 10.
So there's no way around like slicing things.
Well, there is.
Yeah, because I'm thinking like there must be some kind of way to keep track of something, and then do a check with a condition.
Yeah, so there's
having a helper function and slicing things.
Yeah, so I'll go ahead and show you. I'll show you the one pass solution I had, and so I'll show you with this one right here. And so there was a couple conditions. I honestly didn't even think this one was gonna work. I was like, let me just try it out. And so with this right here, I'm going to go ahead and create a couple different arrays. So current, let's just say 10 is our current, and our current is greater than the element 2 out. So in this case, that's true. The current element, the 10, is greater than the 7. So that's good. The current is less than the element 2 out. So in that situation, like, that would be...
The element of what?
The current element is less than the element that's 2 out. And then the next is greater than the previous. So let me try to make this simpler for you. So
can you have it full screen, please?
Yeah.
The window, the VS Code window.
Yeah, hold on. I'm going to show you with 2 examples. I'm going to make it even bigger for you.
Yeah, this is complicated, man.
All right, so check this out. With the first one, this one we want, it's going to be true, right? So we start with our first element, we go to our second one, we go to our third one, and our third one, it's greater than our next one. And so our current element is 10. We're able to do these checks right here to determine if it's strictly increasing. So this will be O of n, flawless. So what we do is we check if the current is greater than the element 2 out, current is greater than element 2 out, it is. That means that this element should not be here. This is the element that doesn't belong in the array. Because
what do you mean 2 out?
2 out. So instead of the next one, 2 out. So this is our current element. This is the next element. This is the next element. I'm talking about by 2 out, I mean the next.
Yeah,
So
why are you checking it? Like, why are you not checking like 3 or 4 or
because
whatever?
because if this one, if our current element is greater than this one, then this is the one we have to remove. We know that for a fact. But there's also going to be times where this element is greater than this element, but it's not the current element we need to remove. It's the next element we need to remove. So I'm just showing you how to check whether it's this one or this one that needs to be removed. So if I encounter this 10, and this 10 is greater than the element that's 2 out, I know that this 10 is the one that needs to be removed. It's not the 5. And so
How do you know that?
Because this 10 is greater than the 7. It's not just greater than the 5. It's not just greater than the 5. It's greater than the 7 as well.
Okay, but the thing is, like, you're checking for the last element of the array.
No, I'm just checking for the one that's 2 out. So I know that I just iterated from the 1 to the 2 to the 10. And the reason why I'm stopping at this 10 is because I know this 10 is greater than 5. So I know this 10 is greater than 5. It's possible though that this 10 is a 6. And so the 10 is greater than the 5, right?
Yeah.
But it's less than the 7, so I could remove the 5 or the 6. They're both still strictly increasing. You know what I'm saying? So, but I'm going to show you a couple different checks. So it's not just that check. The first check I need to do is check. I already know that the 10 is greater than the 5. So now I compare the 10 to the element that's 2 out. If the 10 is greater than the element that's 2 out, then I know for sure that the 10 is the one I need to be removed, because the 10 is not only greater than the next one, it's greater than the next one. If it's greater than the next one, it's the one that I need to remove. So then I check if the current is less than, the element that's 2 out, then it's good. Then it could stay. I don't have to remove this one. So if it's 6, for example, then I don't have to remove this element. I might, but I don't have to. But it is a 10, so we'll keep it there for now. Then I checked if the next is greater than the previous. So I check if the one after the 10 is greater than the 2. If the one after the 10 is greater than the 2, then it's good. So in this specific example, the current element is greater than the next element, so I know that's the one I need to remove. And the 5 is greater than the previous element, so I know this is the one I need to keep, because it's strictly increasing. And then if the next is less than the previous, so if this one is less than the 2, that's bad. That's bad. Then I know that this is the one I need to remove. So let's just say it's like this. Let's just say we have that array. Now in this situation, if the 6 is still greater than the 3, so I stop at the 6, right? Because the current is greater than the next. But the current is also less than the next, so that's good. We know that the current is the one that we need to keep. But the next is less than the previous, and so we know that the next is the one that needs to be removed. So
yeah, I think I need to see some code, man, because it's getting hard for me to understand.
No, it's just very, very simple checks. I keep changing the array on you, so let's just do it with this one and with the original state. And so I go to the 1, I go to the 2, I go to the 10. Okay, the 10 is greater than 5, so I stop here. I do some checks. I check the current element versus the next element. That's good. That's going to return a good response. I check the previous element with the next element, so the 2 and the 5. That's good. Actually, the 10 and the 7 is bad. The 2 and the 5 is good. So one of them.
Sorry. Just see if I understand. So you're comparing nums I with nums plus 2, right? But you're also comparing nums minus 1 with nums plus 1. Those are the two checks.
Yes. Yes.
Okay.
Because if I have one good and one bad, so like 10 and 7, that's bad. 2 and 5, that's good. If I have one good and one bad, that's okay. I could keep iterating over the array. But if I have two bad, so if I had like, this was the example,
so you're basically using the OR operation. You have two conditions. One could return false and the other true, and therefore we would get false. Both could return true, we would get true, or both would return false and then we get false by using these two conditions.
If we stop and do any of these checks, one is true no matter what.
Okay, so
one is going to be true no matter what. One is going to be true. It's either going to be true and false or true and true.
So you need both to be true.
If both are true, we break out right away. So in this case right here, where let's just say we hit our 1, we hit our 5, we hit our 8. Now 8 is greater than 3. So 8 is greater than 7, that's bad. So 8 is the one we need to remove. But also 3 is less than 5. So 3 is also the one we need to remove. So in those two checks, I see that there's 2 that need to be removed to create strictly increasing.
Okay.
If we remove 8, it's still not strictly increasing. If we remove 3, it's still not strictly increasing. So if both of the responses are bad, we could just break out right there.
So so instead of checking the next one with like current plus 1, we're doing plus 2, and this way we can do it more efficiently somehow.
Yeah, we could check. Yeah, we could check our current against. We already checked our current against our next. That's bad. We know that our current is greater than our next. Then we check our current against our next. If that's bad, so nums I and nums I plus 2, and then if nums I minus 1 and nums I plus 1 is also bad, we could just break. Because we know that we have to remove 2 and we can't remove 2.
Okay.
So that's that check right there. So I'm just going to say iterate over nums array. Inside here, if we ever encounter a current element that's greater than the next element, then we check if current element is greater than element 2 out. So I plus 2.
Yeah.
And this is current element is I. And previous element is previous element is
greater than I plus 2, like 1 out.
Next element, yeah. So I plus 1. So previous element.
If both are true, you break out and do what?
You just return false right away.
Okay.
So if nums I is greater than or equal to nums I plus 2 and nums I plus 1 less than or equal to nums I minus 1, then we just return false. Now that's one condition. We're able to just check like a couple of the numbers once we detect that anomaly. Like once we come to a current element that's greater than the next element, now we could just expand out a little bit, do a little bit of extra checks with these right here. So instead of just checking our current and our next, we're actually checking our previous, our current, our next, and our next. That gives us way more information, and that's still O of 1 operation. Now the only other problem is if one of those return true and the other one returns false, or both of them return false, we still know that we detected one that's greater than the next one. And it's possible that somewhere down here, 14, 18, and then 15, somewhere down here we might have another one where like 18 is greater than 15, but for the most part it's steadily increasing. So if we had, let's just go back to our original where we could have just removed our 10, right? So 1, 2, we could have just removed our 10, we'd have our strictly increasing with 1, 2, 5, 7. But if we had like 12, 14, 18, 15, so we have our 10 and our 5, which is the anomaly, and then we have 18 and 15 down here. So the only thing we need to check now is if we ever encounter another one. Once we encounter this, we check to see if this is true, both of it. If they're not, we need to know that we already encountered one of these anomalies. And so the first thing I do, once I encounter, I'm gonna have a flag, which is called first. So this is like the first time I encountered it, and it's true. But in the beginning of the array, I'm gonna set first equals false. So I haven't encountered any yet. But once I encounter it, so like if I hit this check right here, and I do this check, I'm gonna automatically set first to true because I know I encountered this. Now, if at any time in the rest of the array that we encounter another anomaly, if this is already true, we just return false. And so, let me actually do this in order. So let I equals 0, well I is less than nums.length, I plus plus. If nums I is greater than or equal to nums I plus 1, so that's just our current element and our next element. The first thing we do is just check if we've encountered an anomaly yet. And we could do that by just doing if first equals true, just return false. We've already encountered one, so we've already run this code. We've already set first to true, so we know we already encountered.
Okay.
If this is true, then this is the second one that we've encountered, and if it's the second one we've encountered, we just return false.
Wait a second. Isn't first always going to be true for each iteration?
No. So you can see in the beginning of the array, I set first to false. So in this,
but once you get inside the for loop, line 8, you do the check. It does. Oh, okay, because it's inside the if. Sorry. Yeah.
Yep,
I'm bad.
Exactly. So we check our 1, good, 2, good, 10. Okay, this is our first one right here. So our current element is greater than our next element. So nums I is greater than nums I plus 1. So we check, is first true or false? It's still false. So we check this. We compare our 10 against our 7. We compare our 2 against our 5. So the 10 and the 7 returns true, but the 2 and the 5 returns false. Mm-hmm. So that's good. And then we set first to true. So we just encountered our first anomaly. That's our anomaly detection.
Okay.
And then we go to 5, good, 7, good, 12, good, 14, good, 18. 18 is greater than 15. So once we get nums I is greater than or equal to nums I plus 1, first is set to true. We've already encountered one.
Yeah, so you return false because you already have it.
Exactly.
Okay.
Exactly. And this is O of n, no extra space. O of n time and O of 1 space. So this is.
Can we check it on LeetCode?
Yeah.
Or have you checked it already?
I did check it in LeetCode. I was actually a little surprised.
Surprised, right?
I didn't know if it was gonna work just because those checks seemed kind of random at first, but I was like, oh okay, and it's actually pretty
wow.
good.
Pretty good.
Yeah, it's a solid solution.
Really good. Okay.
You kind of have to like play around though, sort of like what you were doing with your previous solution. Like there might be something there. You just have to play around and test it a bunch of times and see what works. But I've also done that before where I've wasted like an hour and a half and I'm like, I can't get it.
How could I think of that? That's what the problem. Like, how would I think of that? Like comparing two out and stuff like that, or doing like first check and then flagging as true or false or whatever. That's what I'm struggling with here.
Yeah.
How can I think of that? Doing a like if I have a job interview, I'm not gonna think of that. That's a terrible feeling, knowing that I'm not gonna be able to come up with something like this on spot.
Well,
Unless I've seen.
you know that if there's two places where current is greater than next, then you could just break. You know that it's false. Like if in the beginning of the array there's a current that's greater than the next, and in the end of the array there's a current that's greater than the next, you could just break. You know what I'm saying? Like if there's two somewhere.
Okay.
So what I did was I just tested for two.
Yeah.
Anytime we encounter one, because it's more likely that you're gonna have two. It's more likely that you're gonna have two that need to be removed if you encounter one than anywhere else in the array.
Yeah, I think I understand what you mean. So, because you could have two of those, and so, and if you're not checking for like if you stop at 10, and see 10 is larger than 5, and that's enough, then you could that could lead you to mistakes, because even if you remove 10, you still have 18, which is bigger than 15. Mm-hmm. So you want to make sure you have more than one, so you don't have false flags, right?
Yeah. Yeah, I mean, look at the second example here. Like, let's say we iterated over this one. We're at 2, then we're at 3, and 3 is greater than 2, so that's true. That's bad. And 1 is also less than 2, so that's true, and that's bad. So right in here, we see that there's 2 that need to be removed. It's either the 2 and 3 that need to be removed, or the 1 and the 2 that need to be removed. That's I kind of thought of it just looking at this one right here, because I'm like, okay, if I land on the one that's greater than the next one, can I compare this to like this, or can I compare this to, do I have to just compare it to this, or can I compare it to other things, and then can I compare this to, and I could detect whether there's more than one that needs to be removed in a 4-element sequence. And if you encounter one that's greater than the next one, you're more likely to find 2 elements in that 4-element sequence that need to be removed. Because either there's 2 that need to be removed, or there's 1 that needs to be removed in that 4-element sequence. There's never 3 that needs to be removed. It's always just 2 or 1.
I think the issue is that this problem requires more thinking than the allotted time here. Like I can't think of a solution that good in like in such a short time.
You know how I selected the last 2 problems?
Yeah, like I've been struggling recently.
You should
to come up with solutions.
You should be. The way
I know.
The way that I selected these problems is I clicked on acceptance. So the acceptance percentage. So like out of 100 people who submit a solution for this problem, only 13.5. So 14 out of 100 people is accepted. So
that's a hard problem though.
Yeah, but look, remove letter to equalize frequency.
Isn't that weird? Like
I know.
That should be a harder problem than easy, right?
And then
same here. Many people are having the same issue.
Remove 1 element to make array. This is the one we did tonight. So about a quarter people. Yeah, because there's edge cases.
Yeah, the edge cases
that's what.
Like for example, yesterday I had the XOR solution, but there was the edge case where you have 3 frequencies, or 6, or not 6, like 3 or 5 or whatever, and then my solution didn't work. That's the hard stuff. Like the edge cases always get me.
Yeah. Because the problems are pretty simple. Like they're not too bad.
Yeah.
But they're just the edge cases. That's it.
Yeah, I think I'd be able to solve it O(n) squared, but I don't think solving it O(n) squared gets you the job, unfortunately.
Yeah. It depends, man. You never know.
Yeah. All right.
Joe, I saw that you said you're taking off. Have a good night, Joe. Thanks for joining us. We'll see you tomorrow or at another meeting. Cool. Thanks for sharing, dude. Awesome. Cool. All right, then I guess we'll be, it's 9:36, so we'll be hopping off, and then, yeah, Daniel, you can hit me up anytime. I'm sure I'll see you tomorrow night, though.
Absolutely, yeah.
Yeah. All right, have a good day tomorrow. I will chat with you soon. Thanks again, Joe, for popping in tonight. We will talk to you soon as well.
Okay, bye.
See you.